In question number 21, it says that two sound waves of wavelength lambda 1 and lambda 2 produces n beat per second. The speed of sound is given that lambda 2 is greater than lambda 1. So we know that the frequency is inversely proportional to the lambda. So we can say that the frequency of 2 will be lesser than frequency of 1. And we know that the beat is what? Beat is the difference in frequency, right? So we can say that according to the question, difference in frequency is given as n. And we know that frequency is what? Velocity by wavelength. So we can write v by lambda 1 minus v by lambda 2 will be equal to n. We have to calculate the speed of sound, that means v. So v will be equal to n into lambda 1 lambda 2 upon lambda 2 minus lambda 1. So my option number 3 will be the correct choice. Now let's move to the question number 22. In question number 22, it says that a stationary source of sound wave is having frequency f0. Sound is reflected from a large vertical plane surface moving towards the source with a speed v. If speed of sound in medium is c, then frequency of reflected wave received by an stationary observer near the source is. So let's say this is a stationary source and this is our vertical plane. This vertical plane is moving towards the source with speed v and the velocity of sound is c. So we know that first the sound will move from the source to the wall, then gets reflected and comes back towards the source. So first we will write the equation from the source to the plane. So if I write for this, we can say that here when the sound is moving from the source towards the plane, then the source will be this at rest. So velocity of the source will be 0 and the plane will behave like an observer and it is moving opposite to the velocity of sound. So we can say that our velocity of the observer will be equal to minus v. So from the formula of Doppler effect, we can say that our apparent frequency received by the plane will be equal to c minus velocity of the observer by c minus velocity of the source into original frequency. So from this we can say that c minus v divided by c minus 0 into original frequency f. So f1 will be equal to c plus v by c into original frequency. So this is the frequency received by the plane. Now the sound wave will get reflected and comes back to the source. So let's say we solve it from the plane to source. So this plane will behave like a source and source will behave like an observer. And since the plane is moving in the direction of the velocity of sound in the second case, so we can say that our velocity of the source will be equal to plus v. And since this source will behave like an observer, so we can say that velocity of the observer will be 0. So the apparent frequency will be equal to, from again Doppler's formula, what will be the actual frequency, since this is the frequency reflected by the plane, right? And we know that whatever the frequency is received by the plane, that will get reflected. So we can say that this will be equal to our f1. So if I put the values, we will get c minus 0 upon c minus v into c plus v by c into f. This is our frequency heard by the source. So by this calculation we can say that the reflected frequency heard by the source will be equal to c plus v upon c minus v into original frequency. So we can say that our option number 1 will be the correct choice. Now let's move to the question number 23. In question number 23, it says that an ideal organ pipe resonates at successive frequency of 50 Hz, 150 Hz, 250 Hz. If speed of sound is 340 meter per second, then pipe is. So as you can see that if this 50 is taken to be x, we can write this as a 3x. We can write this as a 5x. So as you can see that this is all of the odd harmonics, right? So there is only odd harmonics, and we know that in closed organ pipe there is always only odd harmonics. So this open and open will not be possible. So only possible choice is the closed organ pipe, right? And we know that the difference between two successive resonance frequency of any closed organ pipe will always be equal to V by 2L, right? And what is the difference? Since it is 150, it is 50. So we can write 150 minus 50 will be equal to V by 2L. So what we have to calculate? We have to calculate the length. So length will be equal to V by 2 into 100, because 150 minus 50 will give you. So velocity of the wave is 340. So 340 divided by 2 into 100. So you will get 1.7 meter. So my option number 4 will be the correct choice. Now let's move to the question number 24. In question number 24, the fundamental frequency in an open organ pipe is equal to the fifth harmonic of a closed organ pipe. So what is the fundamental frequency of open organ pipe? The fundamental frequency of open organ pipe will be equal to V in by 2L, right? But since it is an open organ pipe, so let's write it LO, that is length of the open organ pipe, and it is equal to the fifth harmonic of a closed organ pipe. So fifth harmonic means 5 times of fundamental frequency. So fundamental frequency of closed organ pipe is V by 4L, where this length is length of the closed organ pipe, and since it is a fifth harmonic, so we should multiply it with 5, and they are equal, so they must be equated. So V will cancel out. So we can say that length of the closed organ pipe will be equal to 5 by 2 into length of the open organ pipe. Now what we have given? It is given that if the length of the open organ pipe is 10 centimeter, length of the open organ pipe is given, the length of the closed pipe is, so we have to calculate the length of the closed pipe. So that means 5 by 2 into 10, and that will give you 25 centimeter. So my option number 3 will be the correct choice. Now let's move to the question number 25. In question number 25, it says that Doppler effect of sound depends on. We know that the Doppler effect depends on the relative motion between source and listener, right? That means rate of change of distance between source and listener. So option 1 says intensity of sound wave. No, this is wrong. Distance between source and listener. No. Relative distance. No. The rate of change of distance between source and listener. So this is also wrong. Option 3 says relative velocity between source and listener. Yes, this is our correct. So we can say that our option number 3 will be the correct choice. Now let's move to the question number 26.